In January 2010, an explosion occurred in the Chemistry and Biochemistry department at Texas Tech University in Lubbock, Texas. The blast happened during research involving explosive compounds and resulted in severe injuries to a graduate student. U.S. Chemical Safety Board investigated and released a case study highlighting systemic safety management deficiencies at the university and broader gaps in academic lab safety practices. The storyline. 2 graduate students were conducting research on a high-energy compound derived from nickel hydrazine perchlorate, NHP. Investigators believed that they had verbally established a set of 100 mg limit on the amount of energetic material that could be produced. The CSB investigation found there was no formal system for communicating this limit or verifying compliance. Initially, the compound was made in small batches, but the students decided to scale up the synthesis to about 10 grams so they would have enough for all planned tests. They assumed keeping the compound wet with solvent would prevent it from detonating. After noticing clumps in the large batch, a student attempted to break them up with a mortar and pestle. The compound unexpectedly detonated by the friction, causing severe injuries, loss of 3 fingers, perforation of an eye, and other burns and cuts to the student. Investigators also found that there were 2 near-miss incidents in the same research group that had similar causes but were not formally learned from or communicated widely within the department. What are the causes of this horrifying incident? Poor communication and misunderstanding. The supposed mg limit for energetic materials was only verbally agreed upon and not formally documented or enforced. Unsafe decision-making. The students chose to scale up the amount of energetic materials well beyond previous batch sizes, without adequate hazard assessment or controls for such a scale. They believed that keeping the compound wet would prevent detonation, a hazardous assumption that proved false. Lack of oversight and follow-up. Previous near misses were not formally reported, reviewed, or communicated across the department, meaning lessons were lost and risks went unaddressed. What was done after the accident? University changes. Texas Tech revised and expanded its chemical hygiene plan to better identify and control physical hazards, not just exposure hazards. The university developed an incident and near-miss reporting system to record, track, and communicate lessons learned from accidents and near-miss. Texas Tech retained the Laboratory Safety Institute to consult on improving safety culture and formed an institutional laboratory safety committee to advise on policies for high-risk chemicals. Broader safety recommendation. The CSB recommended that the American Chemical Society, ACS, develop hazard evaluation guidelines tailored to research laboratories to help researchers effectively assess and control risk. OSHA was urged to issue a safety bulletin emphasizing the importance of controlling physical hazards in academic laboratories. The case study highlighted the need for universities and funding agencies to ensure safety systems are in place before research begins and that safety culture should be strengthened throughout academic research settings.
Post-accident photos and video show extensive damage as the explosion fractured the lab bench, shattered bottles, and sprayed the lab with projectiles.